Hey Trick Class, let's look at this example from 11.3. We're trying to come up with the equation from an ellipse, just from its graph. So I'm going to drag this down and this wider just to be able to zoom in on this to get some key points from it, because you want to be able to see where the major axis ends and where the minor axis ends, all that stuff. So I can see the center of this is at 2, -2. So that tells me that I'm going to have an x minus 2 squared and a y plus 2 squared. Right, that's going to equal 1. And now we're going to basically counting how far left, right we go, how far up and down we go. So if you count here, that's at positive 2 for the x direction. That's 3, 4, 5, 6, and I can tell that's 7 because it's marked at 7. So don't just count and think that these have to be ones. Look at the numbers they give you and make sure the tick marks are 1 unit in length, because it doesn't have to be. That could have easily been like 12. And this would have been, up counting up in 2s or something. So just be careful. So count it over. These are ones at a time. So this is 1. Or sorry, this is 3, 4, 5, 6. So that's 6 for that tick mark. So that means I move to the right 1, 2, 3, 4 units. So I square 4, I get 16. That's the denominator here. Remember, it's a squared. And then the smaller distance is b. So that's up 1, up 2. Again, you can tell I went from -2 to 0. There's 5, so if I went down, there's -4. So you can see that each tick mark in this direction is also 1 unit. So I went up 2, that's 2 squared is 4, that's 4 for that denominator. So there's my equation. I need to squeeze this back up so I can get in here. Right, fraction first. 16 is that denominator plus fraction again, and then 4 is that denominator. So that's how we can get the equation of an ellipse. Oh, sorry, that should be x minus 2. Just typo there. That's how we can get the equation of an ellipse from its graph.